As we drift into the vast uncharted realms of space, we embark on a journey that spans eons and encompasses the mysteries of the universe itself. In the endless expanse of the cosmos, there is so much to wonder about: the birth of stars, the delicate dance of planets, and the invisible forces that bind everything together. From the first flicker of light at the beginning of time to the cosmic depths we explore today, the universe unfolds as both a place of boundless beauty and profound mystery. In this series, we will travel through the heart of the universe, beginning with the story of its birth, the explosive, transformative event known as the Big Bang. We will explore the birth of stars and galaxies, the incredible forces that shape planets like Earth and Mars, and the strange, haunting phenomena that continue to puzzle scientists. With each chapter, we will drift further into the unknown, from the curious storms of Jupiter and Saturn to the haunting quiet of dark matter, a force that pervades the very fabric of existence, invisible yet essential. As we glide through space, we will contemplate not only the wonders of distant planets like Uranus and Mars, but also the quiet, elusive threads that weave through the universe, holding everything together. We'll take a closer look at the Great Red Spot on Jupiter, the hexagonal storm on Saturn, and the mysterious disappearance of water on Mars, all while exploring the profound questions that linger on the edge of our understanding. But our journey does not end there. As we approach the final chapters, we will turn our gaze toward the distant horizon, contemplating the ultimate fate of the universe. Will it stretch forever, its galaxies drifting apart into a quiet, peaceful end, or will it spiral into chaos, collapsing in on itself in a cosmic crunch? The universe's end is a mystery still unfolding, and as we near the conclusion of this cosmic odyssey, we'll explore the possibilities, embracing the unknown that lies beyond. This is not just a journey through space, it is a journey through time. From the very beginning, when the universe was born from a singularity, to its possible future, when stars fade and galaxies vanish, we will wander together through the timeless wonders of the cosmos. Each chapter is a stepping stone, leading us deeper into the mysteries that define our existence, from the atomic to the cosmic scale, with each discovery inviting us to reflect on our place in the vast expanse of the universe. So let us begin this quiet journey, where each chapter unfolds like a star, illuminating a new corner of the cosmos. In the darkness of space, we will find not only the answers to some of our greatest questions, but also the questions that continue to guide us forward into the infinite wonder that surrounds us. Let the beauty of the universe soothe you as we travel through time and space, embracing the mystery that is the cosmos. For as long as humanity has existed, our eyes have been drawn to the vastness above us, to the endless tapestry of stars that adorn the night sky. From the first flickers of consciousness, we have stood on the earth and gazed upwards, wondering, asking questions that echo through the ages. What is this universe? How did it come to be? These questions have been with us since the dawn of civilization, and they remain with us still, carried forward by every generation of dreamers and thinkers who seek to unravel the mysteries of the cosmos. In ancient times, long before telescopes and advanced technologies, humans wove stories about the stars. The Babylonians, with their intricate and mystical beliefs, saw the heavens as a reflection of the divine, a vast and intricate system that governed their lives. They charted the stars and planets, giving them names and stories, mapping the heavens as though the night sky were a grand book waiting to be read. To them, the stars were not mere points of light, but living entities, gods and goddesses, whose movements could predict the future and guide the fates of kingdoms. Across the world, other ancient cultures looked up with the same sense of wonder. In China, the stars were connected to the cycles of nature, and the movements of the celestial bodies were thought to influence life on Earth. The Native American tribes, with their deep connection to the land and the sky, saw constellations as part of their creation myths, a celestial narrative that tied them to the land and to the spirits of their ancestors. These stories, full of gods, cosmic battles, and celestial creation, painted the sky as something sacred, something beyond the reach of the everyday world, a place where the divine dwelled. But as time passed, the questions grew sharper, more precise. Humans began to see the stars not just as myths, but as something that could be understood, something to be explored. In around 600 BCE, in the bustling city-states of ancient Greece, a shift in thinking began. The great philosophers of this time, Thales, Anaximander, Pythagoras, began to see the universe not as the realm of the gods, but as a place that could be understood through reason and observation. The stars, the planets, and the movements of the heavens became subjects for study, not just subjects of legend. This was the birth of cosmology, the birth of a quest to understand the very nature of reality. Pythagoras, with his belief in the harmony of the cosmos, saw the universe as a vast musical symphony where the movements of the celestial bodies were governed by mathematical principles. This idea, though seemingly simple, hinted at something profound, that the universe might be ordered, that it might be governed by laws that could be discovered and understood. The cosmos was not chaotic. It had a pattern, a rhythm, just waiting to be uncovered. This early spark of curiosity and reason would grow over the centuries, fanned by the flames of great minds who would follow. Aristotle, the philosopher and scientist, would propose a geocentric view of the universe, in which Earth stood at the center, surrounded by the planets and stars. Though wrong in many of his ideas, Aristotle's work laid the foundation for the next phase of human understanding, offering a model that would guide thinking for over a millennium. As the centuries passed, the great thinkers of the medieval world carried the torch of this quest for understanding, refining ideas, building upon the work of those who came before. But it was during the Renaissance that a true revolution in thought took place, a period that would change our perception of the universe forever. Copernicus, Kepler, and Galileo, these names have become synonymous with the birth of modern astronomy. They challenged the long-held belief that Earth was the center of the universe. Copernicus proposed a heliocentric model, placing the sun at the center, and Kepler's laws of planetary motion showed that the planets orbited the sun in elliptical paths, not perfect circles. Galileo, with his telescope, peered into the heavens and saw the moons of Jupiter, evidence that not everything orbited the Earth. These discoveries shattered old views and opened the door to a new era of scientific exploration. And yet, even with these advancements, the universe remained vast and mysterious. The sun, the stars, and the planets were no longer just distant lights in the sky. They were real, tangible objects, governed by the same physical laws that governed life on Earth. But still, the most profound questions remained unanswered. What is the universe made of? How did it all begin? The answers to these questions would not come from the philosophers or the astronomers alone, but from those who dared to peer deeper into the very fabric of space itself. In the 17th century, the work of Sir Isaac Newton marked the beginning of a new understanding of the cosmos. With his laws of motion and universal gravitation, Newton gave humanity the tools to begin to understand the mechanics of the universe. His groundbreaking work explained how planets moved, how the tides rose and fell, and how objects on Earth were influenced by the same forces that governed the stars. For the first time, the universe seemed to be governed by simple, understandable laws, a mechanical system that could, in theory, be predicted. But Newton's laws, though revolutionary, were just the beginning. In the 20th century, Albert Einstein would come to challenge our understanding once again. His theory of relativity, both special and general, altered the way we viewed space and time. Einstein proposed that space and time were not fixed, but flexible, affected by mass and gravity. The idea that time could slow down, that the fabric of space could curve, was as mind-bending as it was profound. Einstein's theory showed that the universe was not just a cold mechanical system, but a living, dynamic entity, constantly evolving, bending and stretching. But even Einstein's theory was just a part of the puzzle. As the 20th century progressed, new discoveries began to emerge that would forever alter our understanding of the universe. The discovery of quantum mechanics, with its strange and counterintuitive principles, showed that the universe at its smallest scales behaved in ways that defied our everyday experiences. The very nature of reality was now being questioned. Particles could be in two places at once. Light could behave both as a wave and as a particle. The universe, it seemed, was far stranger than anyone had imagined. As we move into the present day, we continue to explore the cosmos, reaching further than ever before with powerful telescopes, space probes, and even humans walking on the moon. The mysteries are still there, hidden in the vastness of space, waiting to be discovered. What is dark matter? What is dark energy? How did the universe begin? These are the questions that drive us, questions that may never be fully answered, but questions that we continue to ask. In this journey, we will explore the timeless quest for understanding the universe, tracing the path from the ancient myths and stories to the groundbreaking theories that have shaped modern science. We will venture from the birth of stars to the mysteries of dark energy, from the smallest particles to the vastest galaxies. Along the way, we will see that the universe is not just a collection of stars and planets. It is a cosmic symphony, a vast and beautiful mystery that we as a species have only just begun to understand. In the end, perhaps the greatest truth we will discover is this: the quest for understanding is not just about finding answers, but about embracing the wonder and beauty of the questions themselves. For in the vastness of the cosmos, there is not only knowledge to be gained, but a deeper connection to the universe that stretches beyond our comprehension, a connection that will continue to guide us for centuries to come. The moon has been with us for as long as we can remember. It rises each night, its silver glow gently illuminating the world below, casting shadows that have watched over humanity since the dawn of time. The moon is a constant, its silent presence in the sky a steady companion to Earth, one that seems to be woven into the fabric of our existence. Its pull governs the tides of our oceans, shapes the rhythms of the Earth, and has been a symbol of beauty, mystery, and eternity. From the moment humans first gazed upon it, the moon has held an air of wonder. In ancient times, as people looked up at the sky, the moon was not simply a celestial object, it was a divine presence, a guiding force in the heavens. Ancient civilizations like the Babylonians, the Greeks, and the Egyptians each had their own interpretations of what the moon was, ascribing to it various myths and stories. To the ancient Egyptians, it was the Eye of Horus, an omnipotent god who watched over the world. In the Babylonian traditions, the moon was seen as a god in his own right, Sin, the god of wisdom and time, who guided the lives of kings and queens, weaving fate through the very passage of the lunar cycle. The Greeks, in their philosophical pursuits, saw the moon as a reflection of the cosmos, a symbol of the divine order that governed the heavens. Its phases were thought to mark the flow of life itself, the waxing and waning of the moon, mirroring the cycle of birth, growth, decay, and death. This idea was not just poetic, it was a reflection of the human need to make sense of the world, to find patterns and meanings in the world around them. The moon, suspended in the night sky, was the perfect mystery. It was both familiar and distant, ever present yet elusive, a mirror to the divine and to our deepest human questions. But as much as the ancients marveled at the moon, over time their myths gave way to scientific curiosity. As humans progressed in their understanding of the world, the moon's role in the grand story of the universe began to shift. It was no longer just a divine observer or a mythical figure in the sky, but a celestial body whose very existence posed a series of fascinating questions. For centuries, the origin of the moon remained a mystery. How did it come to be? Why does it orbit Earth so perfectly, locked in a delicate gravitational embrace? Ancient theories suggested divine creation, or that it was the result of Earth's natural formation. Some thought it was a cosmic egg that had cracked open, its halves forever caught in orbit around one another. However, these explanations, while beautiful, fail to fully account for the complex, strange nature of the moon. Then, as human technology and understanding began to evolve, so too did our ideas about the moon's origin. In the mid-20th century, the first hints of a scientific theory emerged, one that would forever change how we thought about our celestial neighbor. The most widely accepted explanation for the moon's formation today is known as the giant impact hypothesis, a dramatic, violent tale of planetary collision. About 4.5 billion years ago, not long after Earth itself had formed, a Mars-sized planet collided with our young planet in a violent, catastrophic event. The impact was so immense that it sent debris and molten rock spiraling into space. Some of this debris, caught in Earth's gravitational pull, slowly began to coalesce and clump together, eventually forming what we now call the moon. The scale of this collision was staggering. It was an event that shaped not just the moon, but Earth as well, setting in motion the conditions that would support life on our planet. The moon in its very creation is a part of Earth's story, its origins intertwined with ours. The collision that birthed the moon was not just a cosmic accident, it was a defining moment in the history of the solar system. The debris from this collision, rich with material from Earth's outer layers, formed the moon's surface. But crucially, the moon was made up of a combination of elements that were lighter than Earth's, lacking the heavy concentration of iron that makes up much of Earth's core. Earth's iron-rich core, which powers our magnetic field, was largely preserved by the impact, but the moon's core, lighter and less dense, contained little iron. This small but significant difference would puzzle scientists for years to come. If the moon was formed from the same debris as Earth, why did it lack the iron-rich core that is characteristic of our planet? Why did Earth and the moon share many similarities in their composition, yet remain so different in key respects? The moon's curious composition has led to a variety of theories, and for decades, scientists have speculated on how this discrepancy came to be. One theory suggests that in the aftermath of the collision, much of the molten debris that formed the moon was stripped of the heavier elements, including iron, which had already sunk into Earth's core during its earlier formation. Another theory posits that the impact itself caused the moon to form in such a way that it couldn't hold on to the heavy metals, leaving it with a much lighter core. Regardless of the specific details, the moon's core remains one of its most enduring mysteries, a reminder that despite our advances, there is still much about the moon and the universe that we do not fully understand. But the moon's mysteries do not stop at its composition. As we look closer at the moon, we discover another fascinating anomaly: its peculiar rotation. Earth spins on its axis once every 24 hours, completing a full rotation every day. The moon, Weaver, rotates much more slowly. In fact, the moon's rotational period is synchronized with its orbit around Earth, a phenomenon known as synchronous rotation. This means that the same side of the moon always faces Earth, while the other side remains hidden in darkness, a part of the moon that has only been revealed through the wonders of space exploration. Why does the moon rotate in this way? Why is it that the moon's face remains fixed toward Earth? Some scientists believe that gravitational forces between Earth and the moon caused the moon to slow its spin over time, gradually locking it in place. As Earth's gravity tugged at the moon, it gradually caused the moon's rotation to synchronize with its orbit, creating the steady, unchanging face we see from our vantage point on Earth. The slow and steady dance between Earth and the moon is a testament to the intricate gravitational ballet that governs the cosmos, a constant, delicate balance of forces that has shaped our planet and its celestial companion. The moon's surface tells a story of ancient violence and cosmic history. It is pockmarked with craters, scars from countless impacts over billions of years. Some of these craters are so deep that they could swallow entire mountain ranges. The scars are evidence of a time when the solar system was much more chaotic, when comets and asteroids bombarded the planets and their moons. These craters, etched into the moon's surface, are like pages in a cosmic history book, telling the tale of a violent, youthful solar system. And yet, despite the violence of its past, the moon's surface remains hauntingly beautiful. From the rugged highlands to the smooth, dark plains known as the Mare, the moon is a study in contrasts. Its surface, a mixture of ancient volcanic rock, dust, and regolith, stretched across a landscape that is as serene as it is desolate. In the stillness of Sagittarius A, the moon's surface holds the echoes of eons of cosmic activity frozen in time. Today, the moon continues to fascinate and inspire. It has been the subject of countless missions, each one uncovering new secrets and mysteries. The Apollo missions, which brought humans to the moon for the first time in 1969, returned with samples of lunar rock, revealing even more about the moon's origins. These rocks, analyzed back on Earth, showed that the moon is composed of many of the same materials as Earth, but with subtle differences that continue to puzzle scientists. The moon's story is not just one of creation, it is a story of connection, of two bodies bound together by the forces of the universe. In recent years, new discoveries have brought even more questions to light. Scientists have found evidence of water on the moon, trapped in the form of ice, hidden in the permanently shadowed craters at the poles. This discovery has sparked excitement about the possibility of using the moon as a base for future space exploration, with its water potentially being used for fuel, drinking water, or oxygen. The moon, it seems, has more to offer than we once realized. As we reflect on the moon, floating gently through space, we realize that it is not just a celestial body. It is a silent witness to the history of our planet and the universe itself. It has watched over us for billions of years, and yet its secrets remain largely untold. There is still so much we do not know about its origin, its surface, its hidden water, and the subtle forces that govern its existence. But in its silence, the moon continues to speak to us, reminding us of the vastness of space, the mysteries that lie beyond our understanding, and the eternal wonder of the cosmos. It is not just a rock in the sky. It is a symbol of the unknown, a constant reminder of the beauty, the chaos, and the mystery that exists beyond our reach. As you drift off into sleep tonight, let your mind wander through the vastness of space, guided by the quiet, steady light of the moon. Its ancient secrets are waiting to be discovered, waiting to be understood. And as you close your eyes, know that the moon is still there, its face turned toward Earth, its silent presence a reminder of the timeless quest for knowledge that we as a species will continue to pursue for as long as we look up at the stars. Mars, the red planet, has captivated humanity's imagination for centuries. It is a place that seems familiar yet distant, a world where ancient rivers once flowed and lakes once shimmered under a pale sky. Today, it is a desolate desert, its surface barren and dry, but hidden beneath this harsh exterior lies the shadow of a more temperate past. When we look at Mars, we see more than just a cold and arid planet. We see the remnants of an ancient world, one that once harbored water in abundance. The question that has lingered in the minds of astronomers and scientists is, what happened to the water on Mars? Imagine, if you will, the Martian landscape millions of years ago. The planet was a place of vibrant rivers and sprawling lakes, its skies filled with clouds that could bring rain to the surface below. This was a Mars that could have supported life, a world that had the potential to be a cradle for life forms of its own. Yet today, all that remains are the faint traces of ancient waterways etched into the surface, river valleys carved by flowing water, lake beds where the stillness of time has settled like dust. Mars, it seems, has undergone a dramatic transformation, evolving from a planet rich with liquid water to a dry and inhospitable world. As we drift through the history of Mars, we are taken back to a time when the planet had a much thicker atmosphere. In those early days, the atmosphere of Mars may have been dense and warm, thick enough to trap heat and sustain liquid water on its surface. But something changed. Over billions of years, Mars gradually lost its atmosphere, and with it, the ability to retain the liquid water that once flowed freely across its surface. The Martian climate grew colder and drier until the rivers ran dry and the lakes evaporated. Today, what remains is a cold desert world with only trace amounts of water, mostly frozen at the peaceful Ols. What caused this dramatic transformation? How did Mars, a world that seemed to hold so much promise for life, become the barren planet we see today? The answer is elusive, and the true cause of Mars's transformation is still a mystery that scientists are only beginning to understand. One of the leading theories is that the loss of Mars's atmosphere was due to the solar wind, the constant stream of charged particles emitted by the sun. Unlike Earth, which is protected by a strong magnetic field, Mars lacks this protective shield. As a result, the solar wind, over millions of years, gradually stripped away Mars's atmosphere, slowly eroding it into space. Without an atmosphere to trap heat, the planet's surface cooled, and liquid water could no longer exist in its liquid form. The rivers dried up, the lakes evaporated, and the once vibrant Martian landscape was left to turn to dust. As we float further back in time, we can begin to imagine the world that Mars once was. Picture the Martian valleys, once filled with rushing streams, carving their way through the landscape like ancient rivers of life. The shores of vast lakes, where water once lapped gently against the land, now remain still and silent, abandoned by the water that once defined them. The geology of Mars, with its layers of sedimentary rock, tells the story of a planet that was once alive with the flow of water. These river valleys, these ancient lake beds, are the echoes of a time when Mars may have been warmer and wetter, a time when life might have had the chance to take root. But what happened to the water? Where did it go? Scientists have long wondered about the fate of Mars's liquid water. Some believe that as the planet's atmosphere thinned, much of the water was lost to space. The lack of atmospheric pressure on Mars meant that any liquid water would have rapidly evaporated or frozen, its molecules escaping into the cold vacuum of space. Others believe that some of the water might have been absorbed into the planet's crust, trapped beneath layers of rock. The water locked away deep within Mars may still be there today, hidden from view. There is another theory that suggests the water could have been slowly destroyed by chemical reactions with the planet's surface. as the atmosphere thinned and the planet cooled, the surface of Mars may have become hostile to the water that remained. The presence of certain minerals on Mars suggests that at some point water may have interacted with the planet's soil, chemically altering its composition and causing the water to become locked in mineral form. If this is true, then Mars' once thriving rivers and lakes may have been absorbed into the very ground beneath our feet, leaving behind only the faintest traces of their existence. Yet despite these explanations, there is still much that remains unknown about the fate of Mars's water. Some scientists believe that liquid water may still exist on Mars, hidden beneath the surface, trapped in deep underground reservoirs. The discovery of underground water would be a remarkable breakthrough in our understanding of the planet, offering the possibility that Mars could still harbor the conditions necessary for life, even if only in the depths of its crust. As we float above the Martian surface, gazing down at the vast plains and craggy mountains, it's easy to feel the weight of its history. Mars is not just a barren world, it is a world that has experience. Said dramatic change, it is a world that once held the promise of life, only to be transformed by forces beyond its control, the loss of its atmosphere, the disappearance of its water. These events have shaped the planet into what we see today. Yet even in its desolate state, Mars still holds a quiet beauty, a beauty born of the time when it was a world much like our own. The landscape of Mars is unlike anything on Earth. Its reddish hue, created by iron oxide on its surface, gives the planet a distinct appearance. The vast, dusty plains stretch out beneath towering volcanoes like Olympus Mons, the largest volcano in the solar system. The Great Canyon system, Valles Marineris, carves its way through the planet's surface like a scar, a reminder of the powerful forces that shaped Mars over billions of years. The contrast between the dry, rocky terrain and the faint traces of water once present is striking, a silent testimony to the planet's lost past. As we observe this barren world, we are reminded of the fragility of our own planet. Earth, with its blue oceans and lush landscapes, is a rare jewel in the vastness of space. Mars, in its desolate state, is a cautionary tale, a reminder of how quickly a planet can change, how easily the forces of nature can transform a thriving world into a cold, lifeless desert. And yet, even in this desolation, there is hope. Mars is a world that continues to intrigue us, a world that continues to whisper its ancient secrets to those who are willing to listen. Through the lens of our modern telescopes and through the brave exploration of spacecraft and rovers, we are slowly uncovering the mysteries of this distant world. The search for water on Mars continues, and with each new discovery, we come closer to understanding the fate of the water that once flowed there. Perhaps one day we will find the answers we seek. Perhaps one day Mars will once again be a world that harbors the potential for life. For now, as we drift away from Mars, we carry with us the quiet knowledge that the red planet is not just a barren desert. It is a world that has known water, that has known the flow of rivers and the stillness of lakes. It is a world that holds the whispers of ancient waters, waiting for us to unlock its secrets, to understand the forces that shaped it, and to remember the world it once was. As you close your eyes tonight and drift into sleep, think of Mars, the planet that once was, and the mysteries it still holds. Let its story fill your mind, a reminder that even in the coldest, most desolate places in the universe, there is still beauty, there is still hope, and there are still stories waiting to be uncovered. Mars, with its ancient waters and lost rivers, remains a beacon of wonder in the vast dark sky. And who knows, perhaps in the future we will return to its surface, and once again the waters of Mars will flow. In the vast dark expanse of space, there are few sights as mesmerizing as the swirling clouds of Jupiter. This giant, gas giant planet, the largest in our solar system, is a world of perpetual motion. Its atmosphere, thick with layers of hydrogen, helium, and trace amounts of other gases, is alive with storms, some of which have lasted for centuries. Among these storms, one stands out as the most iconic, the most mysterious, the Great Red Spot. The Great Red Spot is a storm unlike anything we have on Earth. It is not just a cloud, but a massive, swirling vortex of gas that has been raging on Jupiter for at least 400 years, possibly longer. It is so large that it could easily swallow Earth whole, yet it continues to churn in the cold vacuum of space, its winds reaching speeds of over 400 miles per hour. The Great Red Spot is not just a storm, it is a colossal phenomenon, one that has intrigued astronomers for generations. And yet, despite all our observations, this storm still holds many secrets: its origins, its longevity, and its future. As we drift toward Jupiter, we can imagine ourselves moving closer to the vast storm, watching it grow ever larger as we approach. From afar, the Great Red Spot is a magnificent sight. Its deep red colour stands out against the planet's pale, banded atmosphere, where belts of gas swirl in different hues of white, yellow and orange. But the storm is not static, it is constantly in motion, its shape and size shifting over time. For centuries, it has been a feature of Jupiter's face, a swirling whirlpool of gas that refuses to calm despite the passage of time. What makes this storm so remarkable is not just its size, but its persistence. Most storms on Earth are fleeting, raging for hours, days, or perhaps a few weeks before they dissipate. But the Great Red Spot has defied all expectations, lasting for centuries. It is as if it has been there, waiting in the heart of Jupiter, since the very beginning of the planet's formation. How is it possible for a storm to last so long, so unyielding, in the cold expanse of space, where nothing but the gas of Jupiter's atmosphere can keep it alive? To answer this, we must first understand the nature of Jupiter itself. Unlike Earth, which has a solid surface, Jupiter is a gas giant, a planet composed almost entirely of gas, with no solid core to anchor its atmosphere. The absence of a solid surface means that Jupiter's atmosphere is free to move in ways that are different from those on Earth. The powerful winds of Jupiter, combined with its lack of friction from a solid surface, create an environment where storms can grow larger and last much longer than those on Earth. The Great Red Spot, like many of Jupiter's other storms, is a product of this unique atmosphere, a massive swirling vortex of gas fed by the planet's immense size and the immense forces that govern its atmosphere. But the storm's longevity is still a mystery. While Jupiter's atmosphere is constantly in motion, constantly churning with winds and storms, the Great Red Spot has remained a fixture for centuries. Its persistence is likely due to a combination of factors: its location on the planet, the dynamics of Jupiter's atmosphere, and perhaps the unseen forces at play within the planet itself. Some scientists believe that the storm is fed by the constant flow of gas from Jupiter's deep atmosphere, which rises to the surface and fuels the storm's rotation. Others suggest that there may be something deeper within the planet, a hidden engine, a source of energy that keeps the Great Red Spot alive. And yet, despite its enduring presence, the Great Red Spot is not the same as it once was. Over the past few decades, astronomers have observed that the storm is shrinking. Once, the Great Red Spot stretched across the width of 3 Earths. Now it has contracted to about 1.3 Earths in length. This change has raised even more questions. Why is the storm shrinking? What is causing it to lose its power, its size, after so many centuries of existence? Is the Great Red Spot dying, or is it simply evolving into something new? These are questions that remain unanswered, adding to the mystery that surrounds this storm. As we glide through space, closer and closer to Jupiter, we can imagine the forces at work within the storm. The winds that swirl within the Great Red Spot are some of the most powerful in the solar system. They create an unrelenting force, a constant movement of gas that spirals inward, creating the storm's signature vortex. But these winds are not uniform. They are chaotic, swirling in patterns that are difficult to predict. The storm's red colour, which has puzzled scientists for years, may be a result of the chemical composition of Jupiter's atmosphere, with trace amounts of phosphorus, sulfur and hydrocarbons reacting with the planet's ultraviolet radiation to create the storm's distinctive hue. The exact cause of the red colour remains a mystery, adding another layer of intrigue to the already enigmatic storm. As we move past the Great Red Spot, we are left to ponder the many questions it raises. How did this storm come to be? What keeps it alive? And what will happen when it finally fades away, leaving behind only the faint memory of its once mighty presence? The Great Red Spot is a reminder that the universe is full of mysteries, some of which we may never fully understand. It is a testament to the power of nature, to the forces that shape planets and stars, to the immense energy that exists in the vast reaches of space. But the story of the Great Red Spot is not just about science, it is about the awe and wonder that the cosmos evokes. When we look up at Jupiter, we are not just observing a planet and its storms, we are witnessing the vastness of the universe, the incredible forces that have shaped it over billions of years. The Great Red Spot, like the universe itself, is a mystery that invites us to look deeper, to ask questions, to seek understanding. And while we may not have all the answers, the questions themselves are enough to spark our curiosity, to inspire us to explore the unknown. As we continue our journey through the cosmos, we carry with us the image of the Great Red Spot, its swirling clouds, its unrelenting winds, and its deep, mysterious color. The storm, like the universe itself, is a reminder of the beauty and mystery that exist beyond our understanding. It is a symbol of the forces that shape the cosmos, a testament to the power and wonder of nature. And as we drift further away from Jupiter, leaving the Great Red Spot behind, we are reminded that the universe is full of storms, some of which are as old as time itself. They are the embodiment of the forces that govern our universe, the swirling chaos that gives birth to new worlds, new stars, and new mysteries. The Great Red Spot is but one of many storms that populate the vast expanse of space, each one a reflection of the incredible forces that shape our cosmos, each one a reminder of the beauty and mystery that lie just beyond our reach. As you close your eyes tonight, let the image of the Great Red Spot linger in your mind, a symbol of the mysteries of the universe, of the forces that shape our world, and of the infinite wonder that exists in the vast, endless sky. Let it remind you that even in the farthest reaches of space, there are questions that remain unanswered, and mysteries that continue to unfold. The Great Red Spot will continue to swirl on, a silent sentinel in the heart of Jupiter, waiting for us to return, waiting for us to ask the questions that will one day unlock the secrets of the cosmos. Imagine yourself gliding through the cosmos, past the gas giants, past Jupiter, and out into the expanse of Saturn's domain. Saturn, with its golden hues and majestic rings, is a spectacle that stands as one of the greatest wonders of our solar system. But there is something on Saturn that has mystified astronomers for decades, something so strange, so precisely geometric, that it defies the chaos we typically associate with the swirling storms of distant planets, the hexagonal storm at the North Pole. This storm, so perfectly shaped, is unlike any weather phenomenon we've encountered. While storms on Earth and Jupiter form in swirling, chaotic patterns, Saturn's storm at the North Pole takes on an almost otherworldly form, a six-sided shape that seems far too orderly, far too precise to be a mere accident of nature. It is as if the storm itself was designed, sculpted from the chaos of the planet's atmosphere into a perfect hexagon, a shape that echoes through the corridors of space and time, leaving us to wonder, how does something like this happen? As we float closer to Saturn, we can feel the pull of its immense gravity, its gaseous atmosphere surrounding us like a thick, heavy blanket. The hexagonal storm at the North Pole stands out against the swirling cloud patterns of Saturn's atmosphere, its edges sharply defined in stark contrast to the clouds that ebb and flow around it. The storm's six sides are distinct, with each edge stretching for about 8,000 miles, roughly twice the width of Earth. In a vast churning atmosphere where chaos and unpredictability reign, the sharp geometric precision of this storm seems almost impossible, as if nature itself is performing a cosmic dance, orchestrating order from the seemingly boundless disorder of the planet's swirling gases. To the human eye, the hexagonal storm is both a beauty and a mystery. The storm, visible from Sagittarius A, presents a striking contrast to the golden hazy clouds of Saturn that surround it. With each passing moment, the storm shifts and pulses, its swirling violent winds creating the six sides of the shape. Winds that can reach speeds of over 200 miles per hour whip around the edges of the storm, but rather than chaos, the winds follow a pattern, a geometric rhythm that keeps the storm's shape intact, allowing it to maintain its hexagonal symmetry despite the constant motion of the planet's atmosphere. There is a calm, almost hypnotic beauty to the storm's intricate structure, a geometric pattern emerging from the gas-filled chaos. But how does such a perfect shape form naturally in the chaotic, turbulent atmosphere of Saturn? The question of the storm's origin has baffled scientists for decades. In a world where storms are typically amorphous, unpredictable, and ever-changing, how does one form a shape as precise as a hexagon? The answer lies, in part, in the dynamics of Saturn's atmosphere, a place where powerful forces interact in ways that still elude our understanding. Saturn's atmosphere is composed mainly of hydrogen and helium, and its swirling winds are far more powerful than those on Earth. The planet's immense size and rapid rotation give rise to extreme weather patterns. The hexagonal shape of the storm, however, is not a product of mere chance. Scientists have hypothesized that the storm is formed by the interaction of Saturn's rotating atmosphere with the planet's underlying physics. The forces at work create a unique atmospheric flow, a kind of fluid dynamics that results in the six-sided shape. One theory is that the hexagonal structure arises due to the differences in wind speed at different latitudes. Saturn's polar winds move at different speeds than those closer to the equator, and as these winds converge, they form a pattern of vortices, like the eddies in a river. These vortices interact in a way that naturally creates the six-sided shape, a pattern that is stable enough to persist for years, possibly centuries. The precision of the storm's edges is a testament to the stability of the forces at play, creating a perfect geometric shape from the turbulent forces of nature. The storm is not static, however. Like all living things in the universe, it is constantly changing. Observations made over the years by spacecraft like NASA's Cassini have shown that the storm is not only a feature of Saturn's North Pole, but that it evolves over time. While the hexagonal shape remains intact, the storm itself is constantly shifting, its winds changing speed, direction, and intensity. The interplay of these forces keeps the storm dynamic, alive with motion, while still maintaining its defining angular shape. It is a paradox, order in the midst of chaos, a perfect six-sided symmetry that remains elusive yet persistent, and it is this very tension that makes the storm so captivating. As we watch the storm from above, it is as if we are witnessing the dance of the cosmos itself. The wind patterns, the forces of nature all work together to create something beautiful, something mathematically precise, in a place where we might expect only disarray. It is a reminder that the universe, with all its chaos, has a sense of order, a sense of balance that extends far beyond our understanding. We are floating through space, observing this cosmic dance from a distance, and yet we are drawn into the beauty of it, fascinated by the way the forces of nature create something so symmetric, so perfect, amidst the ever-moving ocean of Saturn's atmosphere. And still, even as we marvel at the storm, we cannot escape the questions that it raises. What other mysteries might Saturn hold in its deep, turbulent clouds? Why does this storm persist for so long? And what can it teach us about the nature of planetary atmospheres? The hexagonal storm is but one of the many strange and wondrous phenomena that Saturn holds within its rings, each one a piece of a cosmic puzzle waiting to be solved. Beyond the hexagonal storm, Saturn itself is a world of wonder. Its rings, made of ice and rock, stretch out like an intricate web, their particles reflecting the light of the distant sun in brilliant splendor. As we drift toward the planet, the enormity of Saturn becomes even more apparent. It is a planet so large, so powerful, that its gravity shapes the entire solar system. The planet's storm systems are like the pulse of a giant, a rhythmic heartbeat that moves through the gas, creating swirling patterns and dynamic flows of air. And yet, despite the power of Saturn and its storm, there is a serene beauty in the way it moves. The hexagonal storm, with its sharp geometric edges, floats like a calm, controlled dance in the heart of the chaos. The storm is both an expression of power and a symbol of balance, a reminder that even in the most turbulent of places, there can be harmony. As we drift farther away, the hexagonal storm becomes a distant, mysterious mark on the surface of Saturn, its six sides becoming less distinct as we move farther from its gravitational pull. Yet the storm lingers in our minds, a symbol of the complex beauty that the universe holds. It is a reminder of the mysteries that lie beyond our reach, of the wonders waiting to be discovered, and of the intricacies of the cosmos that remain just out of sight, just beyond the edge of our understanding. Saturn's hexagonal storm, like all the mysteries of the universe, invites us to look closer, to ask more questions, and to seek the beauty in the patterns that emerge from the chaos. It is a reflection of the harmony and complexity that exists in nature, a reminder that the universe is full of order, hidden in the most unlikely of places. As you drift into sleep tonight, think of Saturn and its storm. Picture the six-sided shape, spinning gracefully in the vast gaseous sky. Let its mystery fill your mind, a symbol of the countless wonders that the cosmos holds, waiting for us to find them, to understand them, and to marvel at the beauty of the universe's design. Drift with me now across the black expanse of space, past the cold, distant reaches of our solar system, and toward the rugged red surface of Mars. As we draw closer, we are greeted by an awe-inspiring sight, a colossal solitary peak rising from the Martian plains. This is Olympus Mons, the largest volcano in our entire solar system, a mountain so vast that it makes even the towering peaks of Earth seem small in comparison. Imagine standing at the foot of Olympus Mons, gazing up at its sheer size. Its summit is nearly 3 times the height of Mount Everest, towering 13.6 miles above the Martian surface. The base of this immense volcano stretches roughly 370 miles across, large enough to engulf the state of New Mexico. From its gentle slopes to its towering peak, Olympus Mons casts a long shadow across the Martian landscape, a silent testament to the power and mystery of Mars itself. This giant, which has stood for eons, is not just a geological feature. It is a symbol of the forces that have shaped not only Mars, but the very nature of planetary evolution. But what makes Olympus Mons so extraordinary? Why did it grow to such immense proportions, dwarfing any volcano here on Earth? To understand this, we must first consider the unique environment of Mars. Unlike Earth, where tectonic plates slowly shift and grind against one another, Mars is a world without plate tectonics. On our planet, volcanic activity is tempered by the movement of these plates as they constantly shift, subduct, and evolve over time. When a volcano erupts on Earth, the shifting of tectonic plates can cause the volcano to eventually be buried or even rendered dormant over millions of years. But on Mars, without the same tectonic activity, there is nothing to halt the growth of a volcano once it begins to form. Olympus Mons, like all volcanoes, began as a small vent, a crack in the Martian crust, where molten rock, magma, began to escape. But unlike the volcanic activity we see on Earth, this eruption had no plate tectonics to interrupt its progress. Over millions of years, the lava that poured out of Olympus Mons built up, layer by layer, until it became the immense peak that we see today. The lack of plate movement meant that the volcano could continue to erupt, constantly adding to its size, rather than being gradually worn down or moved elsewhere. Over time, Olympus Mons grew, fed by the endless eruption of lava, until it became the towering giant we observe from space, a reminder of the power that lies within the heart of planets. In its size, Olympus Mons holds a kind of quiet mystery. It is not just its height, but the way it stretches across the Martian landscape, as if the planet itself were reaching out to touch the sky. The volcano's gently sloping flanks reveal the history of its eruptions, layers of hardened lava that tell the story of a planet's slow, relentless transformation. The summit of Olympus Mons is flat, a broad plateau stretching several miles across, almost as if the volcano had reached its apex and then paused in time, holding still beneath the eternal gaze of the stars. As we float closer, we can see the details of Olympus Mons unfold before us. The smooth, undulating ridges of lava that cascade down its sides, the dark fissures and cracks where the volcano has released its fury over the ages. And yet, there is a calmness here. Despite its immense size, there is no sign of recent activity, no volcanic eruptions or billowing clouds of ash. Olympus Mons, though it once raged with fire and fury, is now a quiet sentinel on the Martian surface, its volcanic activity long dormant, yet still a reminder of the planet's violent and transformative past. The sheer size of Olympus Mons raises another question: how could such a massive volcano form on a planet like Mars? The answer lies in the forces that shape planetary bodies and in the particular conditions found on Mars. The lack of plate tectonics is one key factor, but there is another important element to consider: the planet's lower gravity. Mars, with its smaller size and weaker gravity compared to Earth, provides the perfect environment for a volcano of such magnitude. On Earth, the gravitational forces act to limit the size of volcanic mountains, causing them to slow their growth over time. But on Mars, the weaker gravity allows Olympus Mons to grow without restraint, as there is less gravitational pressure to compact the material and limit its height. In fact, scientists believe that if Earth were scaled down to the size of Mars, the same volcano would be several times smaller, unable to reach the immense height we now see on the red planet. This combination of factors, lack of tectonic plate movement, lower gravity, and a steady supply of erupting magma, conspired to create Olympus Mons. But even as we understand the processes that led to its formation, we are left with a sense of awe. For in its size, in its sheer presence on the Martian landscape, Olympus Mons speaks to us not just of planetary mechanics, but of the deep, enduring forces that shape the very nature of planets. It is a reminder that the universe, for all its mystery, is governed by laws that transcend our understanding of the Earth. Olympus Mons, like the rest of Mars, is a world unto itself, a world of history and wonder, shaped by forces that continue to intrigue and inspire. Yet, despite its stillness, there is something almost haunting about Olympus Mons. As we float above its great height, there is an eerie silence that pervades the volcano. It is a silence born of the passage of time, an ancient monument to the forces that formed it, standing still and unmoving in the void of space. Unlike the volcanoes of Earth, which remain alive with activity, Olympus Mons lies dormant, as if the planet has settled into a kind of quiet peace. But this peace, this stillness, is a reflection of the immense history that the volcano carries within its walls. As we continue our journey around Olympus Mons, we are reminded of the contrast between this massive mountain and the barren landscape of Mars that surrounds it. While Earth's volcanoes may erupt and shape their environments with fiery power, Mars's volcanoes stand as silent witnesses to a long-forgotten past. The volcanoes of Mars, and particularly Olympus Mons, are remnants of an age when the planet was far more active, far more dynamic. Today they are frozen in time, monuments to a planet that once had the potential for so much more. But there is something deeply calming about the way Olympus Mons stands, unmoving on the Martian plains. It invites us to reflect, not only on the planet itself, but on our own place in the universe. In the shadow of Olympus Mons, we can feel the vastness of time, the slow unfolding of history, and the inevitable passage of all things. The volcano is not just a geological feature, it is a symbol of the cycles of creation and destruction that govern the cosmos. It is a reminder that just as the volcano was once alive with fire, so too will all things eventually fade into stillness. As we drift away from Olympus Mons, its towering peak gradually shrinking in the distance, we carry with us the quiet knowledge that this mountain is more than just a geological wonder. It is a piece of the history of Mars, a reminder of a time when the planet was vibrant and full of potential, and a symbol of the forces that continue to shape the world around us. Olympus Mons stands as a testament to the power of nature, to the beauty of scale, and to the ever-present mysteries of the cosmos that continue to captivate our imaginations. Let the vast silent presence of Olympus Mons guide you into a peaceful sleep as you reflect on the deep ancient forces that have shaped both Mars and Earth. Let it remind you of the wonders that lie beyond our world, waiting to be discovered, waiting to unfold. The mysteries of the universe, like Olympus Mons, are vast and eternal, and they will continue to inspire us for as long as we gaze up at the stars. Drift with me now across the cold crimson plains of Mars, where the winds whisper through the barren dust and the harsh landscape stretches endlessly in every direction. Mars, a world of striking beauty and mystery, has long been a subject of fascination for humanity. Its vast, empty stretches of land, its deep valleys and towering volcanoes, its ancient riverbeds and frozen plains all seem to echo the silence of the cosmos, leaving us to ponder what secrets it may hold. As we glide through the shadowy Martian terrain, a peculiar thought arises, for we are not just floating through a planet, we are revisiting an enigma that has captured our imaginations for decades. In 1976, the Viking 1 spacecraft sent by NASA to survey the surface of Mars transmitted an image back to Earth that would forever change the way we viewed the red planet. At first glance, the image revealed something so remarkable, so eerily human, that it sparked wonder and awe throughout the world. A face carved into the Martian surface, gazing back at us from the shadows of the planet. This face, which was later dubbed the face on Mars, became an immediate sensation. The world was captivated by the idea that, on a distant, lifeless world, there might be evidence of an ancient civilization, perhaps even a message left for us by a lost alien race. The shape seemed unmistakable, 2 large eyes, a nose and a mouth, all etched into the Martian rock, as if someone had carved a face into the landscape itself. The face appeared to be gazing into the void, frozen in time, waiting for us to discover it. For a brief moment, Mars seemed not so distant and inhospitable, but alive with the possibility of life. But as the Viking 1 spacecraft sent back higher resolution images, the true nature of the Martian face became apparent. The eyes were merely shadows, and the mouth a trick of light and rock formations. Ons, what had once seemed to be an ancient monument, perhaps the sign of extraterrestrial intelligence, was revealed to be nothing more than a natural rock formation shaped by the winds and forces of Mars's ancient eroded surface. The face was an illusion, a figment of human perception, an artifact of our desire to find patterns, to make meaning out of the seemingly infinite emptiness of space. And yet, even as we recognized the face for what it truly was, a natural rock formation, something about it stuck with us. The idea that we could see something so familiar, so human, in a place so distant and foreign, lingered in our minds. It was as if the universe had presented us with a mirror that reflected not just Mars, but our own longing to connect, to find something more in the cosmos, something beyond the cold void of space. The face on Mars, while debunked, left an indelible mark on our collective imagination. As we continue our journey through the dusty, red landscapes of Mars, we are reminded of the human tendency to find meaning in the patterns we see around us. This phenomenon, known as pareidolia, is the tendency of our brains to recognize familiar shapes or patterns in random objects, like seeing faces in clouds or shapes in the stars. It is a gift of human perception, one that helps us navigate the world, but it also leads us to see things that aren't truly there. The face on Mars was a perfect example of pareidolia, a trick of light and shadow that stirred our imaginations and sparked our curiosity about life beyond Earth. But the story of the Martian face is not the only illusion that Mars has presented to us. Over the years, astronomers and space enthusiasts have continued to scan the Martian surface, searching for signs of life, and occasionally new images have appeared that seem to show shapes and structures, forms that at first glance might resemble something familiar, something human. One such image, taken from the same region where the face on Mars was discovered, features a shape that some have called the Martian bunny. Much like the face, the bunny is a rock formation, a natural anomaly on the surface of Mars, but to those who look closely, the shape appears to evoke the figure of a rabbit, ears, body, and all. This Martian bunny, like the face on Mars, has captured the imagination of many, evoking the same sense of wonder and intrigue that our first glimpse of the face did. As we float through the Martian desert, we can almost picture the image in our minds. A small, whimsical figure, carved by the forces of erosion and time, standing on the surface of Mars, waiting for us to find it. The idea of a Martian bunny, nestled among the rocks and dust of a world so distant from our own, is a reminder of the human tendency to see patterns, to make sense of the chaos around us. But beyond these illusions, beyond the face and the bunny, lies the deeper mystery of Mars itself. What does it truly hold beneath its dusty, barren surface? Are there traces of an ancient civilization, or is the planet simply the remnant of a time long past, a place where the forces of nature have slowly carved out its history, one wind-blown rock at a time? The search for life on Mars, whether in the form of ancient microbes or long-forgotten civilizations, continues to captivate us. Each new image sent back from Mars, each new discovery, brings us closer to understanding the true nature of this distant wobby. Yet even as we uncover the secrets of Mars, we are constantly reminded of the mystery of perception. The Martian face and the Martian bunny are both examples of how our minds seek meaning in the unknown, how our eyes are drawn to shapes and patterns that might not exist. In this sense, they are not just illusions, they are reflections of our desire to find something familiar, something comforting in the vast, cold expanse of space. As we drift farther across Mars's surface, we encounter the wind-swept plains, the craggy mountains, and the deep, dark valleys where the ancient rivers once flowed. The planet is silent, but its surface speaks to us in ways that are subtle, profound, and mysterious. Every rock, every formation tells a story of a world that once had the potential for life, a world that, in some ways, mirrors our own. And as we float through this landscape, we cannot help but feel a sense of connection to the past, to the mysteries of the cosmos, and to the possibility that we are not alone in the universe. The Martian face and the Martian bunny are just two of the many illusions we may encounter in our search for meaning among the stars. They are symbols of our collective yearning to understand the unknown, to find familiar shapes in the vastness of space, and to connect with a world so far from our own. Yet, in their very nature, these illusions remind us of the beauty of exploration, the way that even the simplest, most fleeting patterns can evoke a sense of wonder, a sense of curiosity that drives us to look deeper, to ask more questions, and to search for answers that lie just beyond our reach. As you drift into sleep tonight, let the images of Mars linger in your mind, images of the Martian face and the Martian bunny, reminders of the human desire to make sense of the unknown. Let them guide you through the shadowy landscapes of the red planet, where our imagination has shaped the way we see the cosmos. And as you drift further into your dreams, remember that the greatest mysteries of the universe are not always the ones we find, but the ones we create in our search for meaning, for connection, and for the beauty that lies hidden among the stars. As we glide deeper into the quiet, dark reaches of the solar system, the golden hues of the inner planets fade, giving way to the cool, distant blues of the outer worlds. Here, beyond the asteroid belt, in the vast expanse of space, lies a planet unlike any other, a world that defies our expectations and challenges our understanding of planetary formation. This is Uranus, a giant shrouded in mystery, whose peculiar tilt has puzzled astronomers for centuries. It is a planet that does not follow the usual rules of the solar system, a planet that spins in a way that no other world does. Uranus, with its cool cyan blue atmosphere, is often overlooked when we think about the great planets of the solar system. It is not as majestic as Jupiter, nor as colourful as Saturn. Yet in its quiet, distant orbit, Uranus holds secrets that speak to the deep, hidden forces that shaped the solar system. As we drift toward it now, imagine a world bathed in soft, pale blue light, a planet encased in a thick, clouded atmosphere, slowly rotating in its orbit. Uranus is a gas giant, composed mostly of hydrogen, helium, and a bit of methane. It is a world of swirling clouds, with winds that howl through its atmosphere at speeds of up to 400 miles per hour. Yet despite its size, Uranus is often described as an unremarkable planet, overshadowed by its more famous cousins. But as we approach it now, we begin to notice something strange. Unlike every other planet in the solar system, Uranus does not spin like the others. Instead of rotating with its axis upright, as Earth does, Uranus spins on its side, its axis tilted at a remarkable 98 degrees. This tilt is perhaps the most striking feature of Uranus. It is as if the planet is lying on its side, rolling through space like a marble, rather than spinning in the conventional manner we see with the other planets. The tilt is so extreme that Uranus' poles are almost in the plane of its orbit, while its equator lies in an almost horizontal position, a strange and unique configuration among the planets. This odd tilt has left scientists perplexed for years. What could cause a planet to behave so differently? Why does Uranus spin this way, unlike any of the other worlds that share its orbit? As we float closer to Uranus, the mystery deepens. The planet's strange orientation cannot be explained by the usual forces that affect the other planets. It is not the result of gravitational interactions with nearby planets or the Sun, nor is it the result of a natural, gradual process that governs planetary motion. Something must have happened in Uranus's past, something so dramatic that it altered the very way the planet spins. One theory that has been proposed is that Uranus was struck by a massive collision early in its history, possibly with a large planetesimal or a wandering rogue planet. This collision could have been so violent that it caused Uranus to tumble onto its side, altering the tilt of its axis permanently. This violent impact would have been enough to send the planet into a strange, tilted rotation, a state from which it has never recovered. The idea of a catastrophic impact is not far-fetched. The early solar system was a violent place, with planets still in the process of forming and clearing their orbits of debris. Collisions between planets and planetesimals were common, and the remnants of these collisions can still be seen today in the form of craters and moons around many of the planets. It is believed that the Moon itself was formed by a massive collision between Earth and a Mars-sized object. Perhaps Uranus too was the victim of such a collision, a violent event that reshaped the planet and set it on a course that would make it stand out from the rest of the solar system. But if Uranus was struck by a giant impact, why did it not simply settle back into a more typical rotational pattern, like most of the other planets? Why does it continue to spin on its side, locked in an eternal tilt that no other world shares? The answer may lie in the deeper mechanics of planetary formation. Uranus, like all planets, was formed from the swirling disk of gas and dust that surrounded the early sun. But the composition of Uranus, its lack of a solid surface, and the way its gases are distributed, may have allowed the planet to remain in its tilted state. Unlike Earth, which has a rigid crust that stabilizes its rotation, Uranus has no solid surface to anchor its orientation. The planet is more fluid, its gases constantly shifting and swirling, and this may allow the tilt to persist. As we continue to drift toward Uranus, the planet looms larger and its strange tilt becomes even more pronounced. The north and south poles of Uranus, where you would expect to find the planet's most intense atmospheric storms, are instead bathed in long periods of sunlight and darkness due to the planet's extreme axial tilt. One hemisphere is plunged into a continuous winter for half of Uranus's 17.9-hour day, while the other bakes in an eternal summer. This unusual tilt causes seasonal changes on a scale that we can hardly imagine, with extreme shifts in temperature and atmospheric conditions as the planet rolls through its orbit. This phenomenon makes Uranus's climate unique among the gas giants. Unlike Jupiter or Saturn, where the weather systems are constantly in motion, with powerful storms like the Great Red Spot, Uranus's atmosphere is much calmer, with fewer and less intense storms. Yet, despite this relative calm, there is still a sense of mystery surrounding the planet's weather patterns. Uranus's atmosphere, despite its lack of visible storms, contains faint traces of heat emanating from within, suggesting that the planet is not entirely without internal energy, unlike its colder, more distant neighbour, Neptune. Uranus's tilt has even led to intriguing possibilities about the planet's internal structure. Some scientists believe that the planet's strange spin is due to the way its interior is arranged, with large amounts of icy material located deep beneath the clouds. The ice, composed of water, methane and ammonia, could play a significant role in the planet's tilt, affecting the way its atmosphere interacts with the rest of the planet. Perhaps the planet's icy interior contributes to the long, slow rotation of Uranus, while the absence of tectonic activity allows the tilt to persist through the eons. As we move away from Uranus, the image of this tilted giant lingers in our minds. The planet is not just a simple ball of gas, spinning silently in the vastness of space. It is a cosmic oddity, a testament to the complexity and randomness of planetary formation. The extreme tilt of Uranus is both a mystery and a symbol, reminding us that the universe is full of surprises, full of unexpected beauty and wonder. In a solar system that at first glance seems predictable and orderly, Uranus stands out as a reminder that the forces that shape the cosmos are far from simple. There is more to this universe than we can ever truly know, more than we can ever fully understand. As you drift off to sleep tonight, let the image of Uranus's strange, tilted beauty fill your thoughts. Picture the swirling clouds of methane, the soft blue-green hue that envelops the planet, and the way it seems to roll lazily through space. In the quiet stillness of the cosmos, Uranus reminds us that even the most distant, mysterious worlds have stories to tell, waiting for us to listen, to learn, and to wonder. And as you rest beneath the quiet gaze of the stars, this Enk of Uranus spinning silently on its side, a cosmic enigma that carries with it the ancient whispers of the solar system's past and the untold secrets that still await discovery. The universe, vast and infinite, is a symphony of stars, planets, galaxies, and cosmic phenomena. We peer into the night sky and are greeted by the shimmering lights of distant stars, the graceful spirals of galaxies, and the swirling nebulae that birth new worlds. Our minds are filled with awe as we contemplate the vastness of it all, the grandeur of the cosmos, stretching beyond what we can see, beyond what we can ever truly know. Yet as we drift farther into the depths of space, there is something deeply mysterious lurking just out of sight. Imagine, if you will, floating through the cosmos, where the stars form constellations and the planets spin in their orbits. The galaxies are far away, their light flickering like ancient beacons, guiding us through the darkness. But as we travel farther, as we look deeper into the universe, we begin to sense something strange, a presence that is both everywhere and nowhere at once. We know it is there, yet we cannot see it, touch it, or measure it directly. It is invisible, but its influence is felt throughout the universe. This unseen presence is known as dark matter. Dark matter, scientists tell us, makes up a staggering 27% of the universe's mass energy content. Yet despite its vast dominance, it remains an elusive mystery. Unlike the familiar matter that makes up the stars, planets, and us, the atoms that form the building blocks of our reality, dark matter does not emit, absorb, or reflect light in any way that we can detect. It is invisible to our eyes and invisible to the instruments we use to probe the depths of space. In fact, dark matter is so elusive that it cannot be directly detected by any current technology, and yet we know it is there, shaping the very structure of the universe. The first hints of dark matter came in the 1930s, when astronomer Fritz Zwicky noticed something peculiar while studying galaxy cluster. He observed that the galaxies within these clusters were moving much faster than expected, given the visible mass of the galaxies themselves. In fact, the galaxies seemed to be moving so quickly that they should have flown apart, unable to stay bound together by gravity. And yet the galaxies were holding together as if some unseen force were keeping them in place. Zwicky proposed that there must be some invisible matter within the clusters, matter that could not be seen, but that exerted gravitational influence, holding the galaxies together. He called this invisible matter dark matter, a term that would come to define one of the greatest mysteries in modern physics. As we float deeper into the cosmos, we can imagine the vast galaxy clusters where millions of stars and galaxies move through the darkness, bound together by the invisible hand of dark matter. The light from these galaxies shining brightly across space is not the full story. Behind the glittering stars, behind the spiral arms of the galaxies, there is something unseen, an invisible web of dark matter stretching across the universe, shaping its structure and binding it together in ways we are only beginning to understand. But what is dark matter really? What are the forces that give it its strange, unseen power? Dark matter, scientists believe, is not made of the same particles that form the atoms of ordinary matter. Instead, it is thought to be composed of particles that do not interact with light or ordinary matter in the same way. These particles, likely to be much heavier than the protons and neutrons that make up normal atoms, are called weakly interacting massive particles, or WIMPs. These mysterious particles interact with each other and with ordinary matter only through gravity and the weak nuclear force, making them incredibly difficult to detect. Unlike ordinary matter, which interacts with light and other forms of electromagnetic radiation, dark matter is dark precisely because it does not emit or absorb light in any detectable way. Imagine a vast ocean stretching across the universe filled with dark matter particles that pass through us and everything else without leaving a trace. They move silently through space, their presence only felt through the gravitational effects they have on the objects around them. These particles do not shine like stars, nor do they form solid objects like planets. Instead, they pass through the universe like ghosts, unseen and unnoticed, except for the subtle effects they have on the visible matter in the cosmos. As we drift through space, we begin to understand the profound role that dark matter plays in shaping the universe. Without dark matter, the galaxies we see today would not exist in the way they do. In fact, without dark matter, the structure of the universe would be vastly different. Observations of galaxy clusters and the cosmic microwave background radiation suggest that dark matter played a critical role in the formation of galaxies, stars, and planets. It provided the gravitational pull necessary to bring ordinary matter together, allowing the first galaxies to form and cluster together in the early universe. In a way, dark matter is the scaffolding of the universe, a hidden force that shapes the very framework of cosmic structure. It is not just the glue that holds galaxies together, it is the invisible hand that guides the formation of the universe itself, creating the vast cosmic web that stretches across the sky. Without dark matter, the universe as we know it would not exist. It is the unseen force that allowed the first stars to shine, the first galaxies to form, and the first clusters of galaxies to take shape. It is the architecture of the cosmos, invisible yet essential. But as we drift further into this mystery, we are left with an unsettling question. If dark matter is so fundamental to the universe's structure, why can we not see it? Why dis-jaunt? Because it remains so elusive, so far beyond our reach. The answer lies in the very nature of dark matter itself. It is unlike anything we are familiar with. It does not interact with light, nor does it interact with ordinary matter in the same way. It is not bound by the rules that govern the world we see. It exists in a realm beyond our immediate perception, beyond the reach of our senses and instruments. It is not that dark matter is hidden, it is simply that we do not have the means to detect it, at least not yet. Still, the mystery of dark matter continues to inspire and intrigue. In recent years, scientists have turned to new methods in the search for this elusive substance. Experiments deep underground, shielded from cosmic radiation, have attempted to capture the faint traces of dark matter particles as they pass through the Earth. Observatories on Earth and in space continue to scan the cosmos, looking for any sign of dark matter's presence, hoping to catch a glimpse of its hidden form. Despite these efforts, dark matter remains just out of reach, its true nature still shrouded in mystery. As we float further into space, the universe opens up before us, filled with stars, galaxies, and nebulae, vast cosmic landscapes that stretch beyond our comprehension. Yet even in the beauty of this vastness, there is an emptiness, a quiet, invisible presence that lingers in the background. Dark matter is the unseen foundation of the cosmos, a mystery that pervades every corner of the universe, waiting to be discovered, waiting to be understood. We are left to wonder as we drift through the galaxies what secrets dark matter holds. What is its true nature? What is it made of? Is it the key to understanding the very fabric of reality, to unlocking the mysteries of the universe itself? And as we float through the vastness of space, we are reminded that the universe is full of wonders. Some we can see, some we can touch, and some we can only feel, like the gravitational tug of dark matter shaping the universe without us even realizing it. In the quiet of the cosmos, the mystery of dark matter remains both a puzzle and a promise that someday we may uncover the secrets that lie hidden in the unseen reaches of the universe. Until then, we can only drift, floating through the dark, where the mysteries of existence, like dark matter itself, remain just beyond our grasp, waiting for the day when we can finally begin to understand the invisible forces that shape the very fabric of the cosmos. As you close your eyes tonight and drift into sleep, think of the vast, invisible web of dark matter that holds the universe together. Let it fill your dreams with wonder and curiosity as you contemplate the great mysteries that still await discovery in the farthest reaches of space. As we glide further and further through the cosmos, beyond stars and galaxies, the very fabric of time begins to stretch and pulse in a way we can scarcely comprehend. The universe, our universe, has been expanding since that monumental instant known as the Big Bang, an explosion of light and energy that birthed everything we know. From that singularity, the universe unfurled in waves, expanding outward into the vast, dark emptiness of space. Yet, as we float through this endless expanse, an ancient and inevitable question lingers in the air. How will it end? We have witnessed the birth of stars, the life of galaxies, and the gentle swirls of cosmic dust. We've marveled at the violent dances of black holes and the steady hum of distant suns. The universe, as vast as it is, seems to have a rhythm, a pulse that beats through the eons. But in the end, what becomes of this grand orchestra? Will the music slowly fade into silence, or will it crash into a cacophony of chaos? To understand the end of the universe, we must first return to its beginning. In the beginning, the universe was a tiny, infinitely dense point, a singularity, so small that it could not be measured by the tools we have today. But in that singularity, every particle, every force that governs existence was contained. And then, in an instant, it exploded, sending forth everything: time, space, energy, and matter. The Big Bang began the expansion of the universe, and since that moment, it has continued to grow, stretching farther and farther, its galaxies drifting apart as time presses forward. As we journey through space now, we can see the ongoing expansion of the universe in the faint light of distant galaxies. Each galaxy is moving away from us as the fabric of space itself stretches and tears, pulling the galaxies further apart. Yet as we reach further into the unknown, we begin to sense that the universe, it cannot expand forever. Something will eventually change. The question is, what will that change be? Will it all end in a quiet, peaceful fade into oblivion, or will the universe spiral into something far more chaotic? To contemplate the end of the universe, we must first consider the nature of its expansion. In recent decades, astronomers discovered a surprising twist in the tale of the universe's expansion. Not only is the universe expanding, but it is accelerating. For a time, scientists believed that gravity would eventually slow the universe's expansion, pulling everything back together in a great cosmic collapse, a big crunch. but instead, dark energy, an enigmatic force we still don't fully understand, has been pushing galaxies apart at an ever-increasing rate. The force that once bound galaxies together seems to be working against itself now, propelling them apart faster than ever before. This discovery, which stunned astronomers when it was first made, hints at an unexpected and peaceful end to the universe, one that comes not with a bang or a crash, but with a quiet stretching into nothingness. The end of the universe, as we might imagine it, could be a slow, gentle fading, an infinite expansion that stretches out so far that galaxies, stars, and planets are left isolated in the dark void, unable to interact with one another. The universe would continue to expand, its energy growing thinner and thinner, until it reaches a point where the very concept of time becomes irrelevant, where stars no longer shine, and matter ceases to have any meaningful form. This is the heat death theory, one of the most widely accepted ideas about the universe's final fate. Over countless eons, as galaxies drift further apart and stars burn through their fuel, the universe would eventually cool to a point where all the energy that once powered it would be evenly distributed, leaving everything in a state of perfect equilibrium. There would be no more movement, no more stars, no more galaxies, just a vast, cold, empty space where nothing happens, where the once vibrant universe has quieted, like the last fading embers of a long extinguished fire. It is a death that is slow, inevitable, and yet peaceful. But not all scientists agree with this vision. Some have proposed that the universe might collapse in on itself, reversing the Big Bang in what is known as the Big Crunch. In this scenario, the universe's expansion slows and eventually stops as gravity overcomes the force of dark energy. Galaxies, stars, and planets would be drawn back toward one another, collapsing into a dense, hot singularity. In this scenario, time and space themselves would begin to warp and collapse as all the matter and energy in the universe are compressed into a single point. The universe would end in a fiery, cataclysmic explosion, an end to everything we know, a final burst of energy that would begin the cycle again. There is also the possibility of a different kind of end, one that exists outside of our traditional understanding of time and space. Some theories suggest that the universe could tear itself apart in what's known as the Big Rip. In this scenario, dark energy grows stronger over time, accelerating the expansion of the universe so rapidly that it tears apart the very fabric of space-time. Galaxies will be ripped apart first, followed by stars, planets, and eventually atoms themselves as the universe unravels from the inside out. The Big Rip is a chaotic and violent end, a far cry from the gentle fading of the heat death, and yet it is just as much a possibility in the vast, unknown future of the universe. As we float through the endless reaches of space, contemplating these possible ends, we cannot help but feel the immense scale of it all. The universe, with all its complexity and beauty, has no clear purpose beyond what we make of it. It stretches out into the unknown, a place of constant flux and change. It is a cosmic dance, where creation and destruction are in constant motion, where the stars are born, burn brightly, and eventually fade away. The ultimate fate of the universe remains a profound mystery. And while we may never know for sure what will become of it, we can find solace in the fact that, just like the stars themselves, the universe has lived through many cycles of birth and death. As we drift further away from the chaos of stars and galaxies, we come to a place of stillness. It is in this quiet space, amid the vast emptiness of the cosmos, that we can begin to reflect not just on the universe's end, but on its incredible journey. The birth of the stars, the formation of galaxies, the creation of planets, all of this has led to the universe we know today. And while its end may seem inevitable, it is also a part of the universe's story. Just as a star's death gives birth to new worlds, the universe's death will one day open the door to new possibilities, new beginnings. Perhaps, as some suggest, the universe itself is part of a never-ending cycle, an eternal rebirth that begins again once it has run its course. In the quiet of the cosmos, we are reminded of the fragility and beauty of life, both in the universe and within ourselves. The universe will one day fade into a quiet, peaceful ending or spiral into chaos. But for now, it continues its journey, its stars shining, its galaxies spinning, and its mysteries unfolding. As we drift through the final reaches of the universe, we come to a deep understanding. The universe's end is not something to fear, but something to embrace. It is a part of the great cosmic cycle that has shaped everything we know, and it will continue to shape the universe in ways we cannot yet fathom. And as you prepare to drift into sleep, think of the universe's quiet end, the whisper of the cosmos as it fades into the distance. Let it remind you of the vastness of existence, of the beauty in the unknown, and of the mystery that lies beyond. The universe, in all its wonder, will continue its journey through time, and in its stillness, we find peace. Let the final whisper of the cosmos lull you into a peaceful slumber as we too, in our own way, continue our journey through the stars.